Welcome to my channel, guys. My name is Swati, and today I'll be starting the basics that are required for VLSI. So starting with digital electronics, it is very important for VLSI. So we need to be very clear about that. So starting with number systems, we have 4 types: decimal, binary, octal, and hexadecimal. Okay. So the base is nothing but the radix. So radix is the base of the number. For decimal it is 10, binary 2, octal 8, and hexadecimal it is 16. So let's see binary now. So binary we have numbers from 0 to 9, and hexadecimal we have 0 to 9 and A to F, where A represents 10, B represents 11, and so on, F represents 15. So in octal we have 0 to 7, and in binary we know that we are very familiar with 0 to 1. And let me just tell you, computer works on binary, not that it understands zeros and ones. It works on and off conditions. Sorry. So now let's see conversions. So starting with the binary to decimal, and octal to decimal, hexadecimal to decimal, and then we'll see decimal to other number systems. Okay. Let's start with binary. So for suppose 01011 is given, and then you have to convert it into decimal form. So how will you convert? You just have to take the weightage and then add them all. Okay. So how will you add the weightage? You have to follow the radix is not, like for suppose you take an example. Here we have taken binary, so the radix is 2. So this is how we take the weightages, and then you just have to add all of them to get the corresponding decimal value. This is applicable for any number. Okay, you can convert any number into the decimal form just by adding the weights. Now let's see octal. So let's take example of 86.5 to the base 8, and then you have to convert it to decimal form. So how will you convert? Simple. You have to just multiply it with the given weights and then add all of them. And for fractional part, you have to multiply it with 8 power minus 1. Okay, not 8 power n. You have to multiply it 8 power minus n. Then you'll get the answer. Next, coming to hexadecimal. So we'll take an example. F represents 15 in hexadecimal. You all know that. So you have to convert into decimal. So remember, F is not present in decimal value, so you cannot take F directly. So we are taking 15. Then we add the weights and you get the corresponding decimal value. Now let's see binary. So how to convert binary into decimal? So in order to convert binary into decimal, you just have to divide the given integral value with the wanted radix and multiply it with the fractional part. Let's do it. Here the required form is 2, the radix is 2. That is why I am dividing the 42, the integral part, with 2. If you perform this, what you'll get? You'll get some value. So after performing division method, you have to take the values from bottom to top. Okay. So this will be your integral value. Now let's see the fractional part. You just have to multiply with the given wanted radix, and whatever you get, you have to take the integral part and again multiply the fractional part with the given radix, and so on. You have to do it until you get the 0 integral part, or else repetition of the first initial value, which is 0.2 in this case. So I'll be stopping my calculation here and taking the values from top to bottom, and this will be my final decimal value. Sorry, final binary value. Now let's see octal. So it is very simple. Let's take an example. So I just have to divide it with 8, and you have to take from bottom to top, and then for fractional part you have to multiply with radix, and that's it. Okay, you have to perform this until and unless you get 0 or the same fractional part of the starting where you have started. So I'm gonna stop my calculation here and take the top to bottom values, and 52.1463 is my answer in octal. Now let's see hexadecimal. So same example I'm taking 42.2 to the base 10. You have to convert into hexadecimal. How will you convert? Simply you have to divide the given integer value with 16 and take from bottom to top values. And for integer or the fractional part, you have to multiply. Simple. So the answer will be 2a.3 because in hexadecimal a represents 11. Okay. Now let's see octal. So we have seen octal to binary and hexadecimal to binary. Let's see it now. So how to convert? Simple. You just have to take equivalent binary values. For octal you have to take 3-bit and for hexadecimal you have to take 4-bit. See if you can follow this 4 to 1 weightage, and then for hexadecimal it is 4-bit. Simple. Okay. You'll understand with an example so that you'll understand clearly. So you have to follow 8421 weightage here, and each integer we have to represent it the corresponding binary form. Okay. Then now let's say bind to octal and bind to hexadecimal. So bind to octal you just have to group it by 3, and for hexadecimal you have to group it by 4. Let's take an example. So here we're taking 101.01. So you have to group 3. If you group 3, you get 5. Here in the fractional part, I don't have extra 0 for appending 0 in the miss B for fractional part. For suppose in my integer part, if I don't have enough bits, then I can append zeros in the LSB, which is the starting. Then to convert octal into hexadecimal, you have to first convert into binary or decimal and then hexadecimal. Similarly, for vice versa, for hexadecimal to octal also, you have to follow the same procedure. So let's take an example. So now I have to convert this octal into decimal first. How will you convert? Simple. You have to divide the integer part with 8 and multiply the fractional part with 8. So you have to perform this like previous questions how we solve. In the similar way, you have to do this in order to get the decimal value. So I'm performing the long division method. So if you perform, you get 215. 15 is nothing but f in hexadecimal, so it is 2f integer part. Now let's say fractional part, you have to multiply with 16 the radix, and I'm getting 4 as a value, so it is 2f.4 is my answer. Okay, so we have to do the same for hexadecimal to octal also. Let's see. For to convert any number in decimal form, just have to add the weights, and for converting decimal to any number, you just have to divide with r and multiply the fractional part with the given radix. For binary to octal, you have to group it by 3. For decimal, you have to group it by 4. And to convert octal to hexadecimal, you just have to convert it first into decimal or binary and then convert it into a hexadecimal and vice versa. Okay. So this is all about, and the final one is octal to binary. You just have to write down the corresponding 3-bit representation, and for hexadecimal to binary 4-bit representation. That's it. For more videos, please like and follow. Before that, let me just give you some homework questions. So these are the homework questions. I want you all to solve this and comment down. I'll be checking the answers, and if you have any doubts, please be free to comment down. I'll be definitely be responding to your questions. Okay, so please solve these questions. These are very important. These are the very useful fundamentals which are very much strongly required for your VLSI journey. Okay, please comment, like and share. Thank you. Bye bye.